Today we are going to do dividing like bases part 1 and part 2. We are actually not going to do the rational exponents one, but we will be doing those two problem streams and then finishing the worksheet from the other day. So let's go to our journal, dividing like bases part 1. That's what we will title it. We're going to start with some simple division problems. 16 over 8. 16 divided by 8. What does that equal? 2, yeah. To what power? Yeah, to the first power, okay. Number 2. Let's change the 16 to a power of 2. What power of 2 is 16? Do y'all know? Four? Yeah, to the 4th. And I write these over here to kind of help me out. So yeah, I'm going to rewrite it as 2 to the 4th over, what about 8? What is 8 as a power of 2? Yep, 2 to the 3rd. And just like we've been doing in the past, we've been expanding them out. Could you close your computer? Y'all don't need them open. Go ahead and tilt them down, please. So we would expand these out and be 2 times 2 times 2 times 2, right? Because there's 4 of them, over 2 times 2 times 2. What do we do whenever we have a number over itself? Simplify it, right? What does 2 over 2 equal? 1. So I'm going to put a 1 over the top of that. 2 over 2 again. 1. 2 over 2 again. 1. So all that we have left on the top would be 1 times 1 times 1 times 2. And on the bottom, it'd just be 1 times 1 times 1. So that ends up equaling just 2. To the first power, right? So 2 ways of solving it out. Okay, let's do 64 over 8. What does that equal? Yeah, just 8. We can also write this as powers of 2 because what? So I've listed out squared, cubed to the 4th. What's to the 5th? 16 times 2, what does that equal? 32. What is to the 6th power? 64. Okay. So we'll rewrite it this time for number 4 as the powers of 2, just so we can see maybe some patterns. So 64 would be 2 to the 6th power over, what's 8? Yeah, 2 to the 3rd power. Now let's expand them out. So 6 2's on top because it's a repeated multiplication. And then 3 2's on bottom. So let's do the same thing as we did on the previous example. Anytime you have a 2 over itself, that equals 1. So what do we have left?
2 to the third power.
2 to the third power. Very good. What is 2 to the third power?
8.
8. Aren't these the same?
Yeah.
Okay, so are you seeing any shortcuts that we could possibly do instead of expanding it out and then simplifying the ones?
Yeah.
What do you think?
64 is something like 8 times 8. And 8 times 1 is okay. So you can do 8 times 8 over 8.
8 times 8 over 8. Okay. Yeah, because 64 is 8 times 8 over 8. And then that would simplify to equal 8. Okay, that's another way of looking at it. Very good. Okay, let's do another one. Let's do a to the 5th power over a to the 2nd power. Okay, so what does this mean? A times itself 5 times. Does anybody have a guess of what this could be? A to the 3rd. Okay. So let's see if she's right. Oh, a to the 3rd because we just have 3 a's left after we simplify. How did you see that?
Just subtract your exponents.
Okay, so let's see. Subtract exponents.
Because they're the same.
Because they're what's the same?
The bases are
Yeah, like bases. Subtract exponents. So divide. Like bases, subtract the exponents. So is that true for all of these? Let's look at this one. If I do 2 to the 6 minus 3, that equals 6 minus 3 is 3. So 2 to the 3rd, which is what we got. That's good. Okay, what about this one? 2 to the 4 minus 3, which equals 2. To the 1st power, right? Which is what we got. Okay, so we're on the right track, I think. Woohoo! All right, let's see. Oh, and this one we could have done a to the 5 minus 2, which was a to the 3rd. So yeah, it works on all of those examples that we've done so far. So let's do 5 to the 5th over 5 to the 3rd. We're not going to expand it out. Let's see if we can just use the rule. How would we do it with the rule?
subtract 5 and 3.
Yep.
You get
So keep the same base because they are the same. 5 minus 3 and get 5 to the second power. Because we could have expanded it out. Okay, let's go to number 7. 2 to the A over 2 to the B. Can we do the same thing? Keep the same base. So what will we subtract? 2 to the A minus B. That's it. And we can't do anything with that. That's it. That's all we can do. Okay, let's do 3 to the third power times 5 over 3. Just multiply there. So whenever you have fractions, you can separate it out, or you can just keep our same denominator, right? That 3. And then we could expand it out. Which we still have a simplification there, which takes one of the 3's away from the top. And then the bottom one is gone. So we're just left with 3 times 1 times 3 times 5, which would be 3 squared times 5. We don't have to expand it out, remember? But I did it just so we could see that. We could have looked at it as 3 to the third over 3 times 5 over 1. You can separate those out whenever you're multiplying fractions. So then we do the same thing here. 3 to the 3. What's the exponent on just a 3? 1 minus 1 times 5, which still equals the 3 squared times 5. Okay, number 9. 2 to the third times 3 squared over 6. Does that look like it can't be simplified? We don't have any like bases. But what do we know about 6? What are the factors of 6? 2 and 3. So I could rewrite this as 2 to the third times 3 squared over 2 times 3. Do y'all see how I got the 2 times the 3? I changed that 6 into factors. A product that makes 6. 2 times 3 is 6. So now I can do these two and those two because they have like bases now. So this is like having a 1. This is like having a 1. So division with your like bases, what do we do? Subtract the exponents. So what are we left with this 2/3 over 2? 2 what? Yeah, 2 squared. And then what about the 3? Just 3, yeah, because that 2 minus 1 will give us 1. That's it. All right, so let's write the rule down here. When dividing like bases, subtract the exponents. All right, we got to move to the next one. Dividing like bases, part 2. This is where it gets fun. They're like, no, not fun. All right, number 1. Now ready? Is going to be 2 over 2 cubed. How is this different from what we had been doing? Where's the bigger exponent on this one? The denominator. Ooh, how's that going to change things? Let's look. Let's expand it out to look at it. So on the bottom, we'd have 3 of the 2's. On top, just 1. Can we still simplify though? Yeah, we can still simplify. So what do we have on top then? A 1, exactly. Over 2 squared. Yep. Or 1 over 4. But this is really what we're looking at. Okay, so how is this different from if we had 2 cubed over 2? It'd be a whole number. What would that whole number be? 2 squared, which equals 4, exactly. So we could still do the same thing. This would be 2 to the 1 minus 3 because we still subtract them. But what is 1 minus 3?
2.
Negative 2. 2 to the negative 2. These need to be the same. Oops, I shouldn't have marked that out. I didn't mean to. Promise I didn't mean to. Handy dandy white out here. These are supposed to be the same. So there must be some kind of rule that says if you have a negative exponent, you take it to the bottom and make it positive. And there is. All right, let's go to number 2. 3 squared over 3 cubed. So this would equal 3 times 3 over 3 times 3 times 3. So what do we do with the 3 over 3? Yep, it equals 1. So what are we left with on top?
1.
Over
3.
3, yeah. So we could have subtracted them like we've been doing. But it's 2 minus 3. So this means what exponent? What's 2 minus 3? Negative 1. This equals this. So I'm going to write that here. 3 to the negative 1 equals 1 over 3. This is a type of rule. If there is a negative exponent, on top, which is called our numerator, move the base to the bottom, or to the denominator. I'm just going to put bottom. And change it to positive. Change the sign to positive. So, did y'all get that rule down? So writing it. So what if we have 1 over 6 to the negative 2? What if the negative exponent's in the bottom? What do you think we do? If it's on top, we take it to the bottom. So if it's on bottom, where would we take it? To the top. Yep. So this would be 6 squared. So the whole thing with negative exponents is to find the reciprocal. Do y'all remember the reciprocal? That's what we are going to use, the reciprocal. So do we want to write this again, but put bottom and top and flip it? Or do we just want to find the reciprocal? Yeah, I think so too. So if there is a negative exponent, find the reciprocal. To make it positive, to change the sign to positive. The exponent to be positive. So let's call this one number 3. Let's do number 4 now. If there's negative exponent, find the reciprocal to change the exponent to be positive. Let's do 5 to the 3rd over 5 to the 5th. We already have our rule. We don't have to extend it out anymore. If you want to, if you need to extend it, that's fine. I'm just going to use the rule. So this would be 5 to the 3 minus 5. Three minus 5 is negative 2. So it's 5 to the negative 2. And we simplify that, right? Because we have a negative exponent. So we take it to the bottom. Basically find our reciprocal, change the exponent to positive. 1 over 5 squared. Okay, let's do 16 m cubed over m to the 7th. Do we do anything with the 16? No. So let's leave 16 up front. What about with the m's? Mm-hmm. So 16 m to the 3 minus 7. So 16 m to the, what's 3 minus 7? Negative 4. Then how do I change this m to the negative 4? Take it down to the bottom, find the reciprocal. What about the 16? Do I do anything with that?
No.
Nope. Keep it. We keep it there. Okay, let's do one more. 4a squared b to the 5 c over 6 a to the 10 b and then c squared. I can separate them out, look at them separately. So what is, let's look at the 4 over 6. What would that reduce to? They're both even. So what could I reduce them by? 2, which would be 2 over 3, exactly. Okay. Then what do I do with the A2 and A10? Yeah, so A to the 2 minus 10. What about B? B to the 5 minus 1, because that would be a 1 there. And then what would C? That'd be a 1 there. 1 minus 2. Okay, the 2/3 is still just out front. Now I do 2 minus 10. What does that equal? -8. So if it's -8, where is the A going to go? On the bottom. So it'll be A to the 8 on bottom. Okay, what about B? 5 minus 1. 4. So is that going to go on top or bottom? Is it positive or negative? So it's going to stay on top. Okay, what about C? 1 minus 2. It's a -1. So where is C going to go? Bottom. C to the +1 or just C? Okay, last week you had an assignment. It said multiplying exponents. You're going to finish that now that you've learned these. I think on the back you were supposed to skip a few. So you're going to do those now. It was this. So now that you've learned the division rule, you can do 7, you can do 9, 10, 12, 5. The only one that's a little different is number 8. So look at number 8. These are just fractions raised to powers, but it's still multiplying. It's like a to the 3rd, a to the 4th, a squared. What do we do with these exponents? Add, exactly. So it'll be 1 over s to the 9th power. That's it. Make sure you keep that parentheses around it. Okay, so your homework tonight is just to finish the rest of this and turn it in.
I don't think I got that.
Let me get you one.